All right. All right, people, I will do this generative AI video. I know I keep getting asked to do the generative AI video. You guys keep telling me to do it. We'll do it.
So we looked at clip embeddings, right? And we've talked a lot about using generative AI to produce new sentences, to produce new images, and so on and so to understand images, all these kind of different things. And the idea was that if we...
I don't know what we're talking about. I feel like I just came into the middle of a video. I must have missed the previous context for this, but okay, we'll figure it out.
We look at enough pairs of images and text, we will learn to distill what it is in an image into that kind of language. So the idea is you have an image, you have some text, and you can find a representation where they're both the same. The argument has gone that it's only a matter of time before we have so many images that we train this on, and such a big network and all this kind of business, that we get this kind of general intelligence, or we get some kind of extremely effective AI that works across all domains. Right? That's the implication. Right? The argument is, and you see it a lot.
This is just how he's just explaining the fundamental basis of an LLM, right? Effectively, what he's saying is that once you get enough, you can generalize over any data sets. This is just MLPs driven out to the logical fullest extent, right?
In the sort of tech sector, from some of these sort of big tech.
He's not explaining LLMs, he's explaining neural nets. Yeah. So it's just an MLP, right?
Companies who, to be fair, want to sell products, right? That if you just keep adding more and more data, or bigger and bigger models, or a combination of both, ultimately you will move beyond just recognizing cats, and you'll be able to do anything. Right? That's the idea. You show enough cats and dogs, and eventually the elephant just is implied. As someone who works in science,
I mean that's the problem about extrapolation. Extrapolation is really, really hard. I don't know about that. I don't know about that business.
We don't hypothesize about what happens. We experimentally justify it, right? So I would say if you're going to say to me that the only upward trajectory is going to, the only trajectory is up, it's going to be amazing, I would say go on and prove it and do it, right? And then we'll see. We'll sit here for a couple of years and we'll see what happens. But in the meantime, let's look at this paper, right, which came out just recently. This paper...
By the way, he is correct in the sense that extrapolated bananas. Something that's really important to always remember is that just because there is a large change in a short period of time, there is no reasonable evidence to believe that a large set of change will happen again in a short period of time. There's only so much of that can possibly happen. And so to always, you always hear this phrase that right now, today, is the worst version of AI that will ever exist. You're absolutely right. I'm sure they'll iterate and get it better than it is today. But the problem is often people paint that in their head from the time in which there was no Copilot to this new magical tokenizing guessing machine that gives you out something that's really amazing, and you're just like, holy cow, it guessed what I wanted, into, again, that level of transition. I don't know if that next level of transition is going to happen again. From nothing to something was huge. From something to the next level, I don't know if it's going to go on. This is toddler level AI, and we may not get better than toddler level AI under this current iteration, under this current local optima. This may be as good as it gets.
Is saying that is not true, right? This paper is saying that the amount of data you will need to get that kind of general zero-shot performance, that is to say performance on new tasks that you've never seen, is going to be astronomically vast to the point where we cannot do it. Right? That's the...
Not only that, a really good quote from C.S. Lewis. There's this C.S. Lewis quote out of The Silent Planet. I know I've mentioned this one specifically a few times, where Ransom lands on Mars and he has no idea where he's at, and he looks out at the seas, the mountains, and the trees. And because it's something new to him, he's never seen before, he is unable to actually see the thing. Even us in our much more advanced, amazing human brains, we can't even see the forest or the trees on this new world. Because, and I'm sure you've experienced this before. Have you ever been to a new place where when you look around, it just looks different? And then as you spend time there, it's almost as if things get smaller. And they get, all of a sudden you see them for what they are versus this first initial experience. And so there's something very, very true to that, where given an AI a brand new experience, is it able to actually do it? Is a human actually even able to do it? It's a very weird experience if you've ever been to if you've ever seen something brand new, it's like you can't even see it. Like you don't even have the ability to filter it. This is a reason why exploring is fun. Exactly.
Right, that's the idea. So it basically is arguing against the idea that we can just add more data and more models and we'll solve it. Right? Now, this is only one paper. And of course, your mileage may vary if you have a bigger GPU than these people and so on. But I think that this is actual numbers, right? Which is what I like, because I want to see tables of data that show a trend actually happening or not happening. I think that's much more interesting than someone's blog post that says, I think this is what's going to happen. So let's talk about what this paper does and why it's interesting. We have clip embeddings, right? So we have an image, we have a big vision transformer, and we have a big text encoder, which is another transformer, a bit like the sort of thing you would see in a large language model, right? Which takes text strings, my text string today, and we have some shared embedded space. And that embedded space is just a numerical fingerprint for the meaning in these two items. And they're trained, remember, across many, many images, such that when you put the same image and the text that describes that image in, you get something in the middle that matches. Right? And the idea then is you can use that for other tasks, like you can use that for classification, you can use it for image recall. If you use a streaming service like Spotify or Netflix, right, they have this thing called a
Netflix mentioned, let's go.
Recommender system. A recommender system is where you've watched this program, and this program. What should you watch next, right? And you might have noticed that your mileage may vary on how effective that is. But actually, I think they're pretty impressive for what they have to do.
It is quite crazy what actually happens. There's so much to that specific part of the business. Man, it is absolutely wild how much goes into it. And to just gloss over that, it's bananas. What is happening inside these engines.
But you could use this for a recommender system, because you could say basically, what programs have I got that embed into the same space of all the things I just watched and recommend them that way, right? So there are downstream tasks like classification and recommendations that we could use based on a system like this.
Yeah.
What this paper is showing is that you cannot apply these downstream tasks for difficult problems without massive amounts of data to back it up, right? And the idea that you can apply, this kind of classification on hard things, so not just cats and dogs, but specific cats and specific dogs, or subspecies of tree, right? Or difficult problems where the answer is more difficult than just the broad category, that there isn't enough data on those things to train these models in an effective way.
I've got one of those apps that tells you what specific species a tree is. So is it not just similar to that?
No, because they're just doing classification, right? Or some other.
Isn't that, is part of this what is this what CAPTCHAs have always been? Just data aggregation? Just getting us to classify for them as proof that you're a human? Isn't that what it's always been? I know that when Google used to do Google Books, I went and interviewed at the Google office in Boston, or in Cambridge, and during the Cambridge time, they had Google Books still in there. And what they would do is they'd actually chop off the spines and then manually, scan every single page. And then all the ones they couldn't parse out with a high degree confidence, they'd actually put into CAPTCHAs and then have the CAPTCHAs solve it for you. Like that was one of the strategies back in the day, was Google CAPTCHA figuring out bananas. Is this bananas or is this banana? The human computation Google Tech Talk. Yeah, it's pretty smart. It's pretty, that's history. That was real. Real history happened there.
Another problem, they're not using this kind of generative giant AI, right? The argument has been, why do that silly little problem when you can do a general problem and solve all your problems, right? And the response is, because it didn't work, right? That's why we're doing it. So there are pros and cons for both, right? I'm not going to say that no generative AI is useful or these models are incredibly effective for what they do, but I'm perhaps suggesting that it may not be reasonable to expect them to do very difficult medical diagnosis because you haven't got the data set to back that up, right? So how does this pay?
The rare event problem. So you can have a really large system that, how do you know that you've released a canary that is actually better than the software that you're currently using? And this comes down to something called the rare event problem, where maybe you have an event that happens only 1 out of every 10 million requests. Like, how do you know that you haven't increased or decreased that problem? It's very difficult. You don't know what you don't know. It's hard. Is that the peaking problem? Data is always collected and is always getting more detailed. I don't know if this is the peaking problem. The problem is that what you need to describe everything becomes exponentially larger. And so you have to continuously have more and more data to get more and more precise. And each level of precision isn't some like linear amount.
Paper do this? Well, what they do is they define these core concepts, right? So some of the concepts are going to be simple ones like a cat or a person. Some of them are going to be slightly more difficult, like a specific species of cat or a specific disease in an image or something like this. And they come up with about 4,000 different concepts, right? And these are simple text concepts, right? These are not complicated philosophical ideas.
Calm down,
right?
Lithium.
I don't know how well it embeds those. And what they do is they look at the prevalence of these concepts in these data sets. And then they test how well the downstream task of, let's say, one zero-shot classification or recall or the recommender systems works on all of these different concepts. And they plot that against the amount of data that they had for that specific concept, right? So let's draw a graph and that will maybe make it more clear, right? So let's imagine we have a graph here like this. And this is the number.
So they're just saying the more data it has, the better it's going to get? Sort of? It just goes like this, though? Some sort of a log curve?
Of examples in our training set of a specific concept, right? So let's say a cat, a dog, something more difficult. And this is the performance on the actual task of, let's say, recommender system or recall of an object or the ability to actually classify it as a cat, right? Remember we talked about how you could use this for zero-shot classification by just seeing if it embeds to the same place as a picture of a cat, the text, a picture of a cat, that kind of process. So this is performance, right? The best case scenario, if you want to have an all-powerful AI that can solve all the world's problems, is that this line goes very steeply upwards, right? This is the exciting case. It goes like this. Right, that's the exciting case. This is the kind of AI explosion argument that basically says we're on the cusp of something that's about to happen, whatever that may be.
We are 11 months into 6 months away from AI stealing all of your programming jobs. We're starting to get about a month into this tweet. Okay, we're on the cusp, people. It's like right there. It's like this close. We're gonna have it. It's almost there. They took our gerbs. It's about to happen at any second. Elon implied. But it's a joke, right? Jump on, please. Devin is not even public yet. You don't even know. I mean, that's what I hear with these things is that we're on the cusp of this great giant change. And I think there's going to be a lot of great change. Like, I'm not some AI doomer, right? I like Copilot. I don't use it anymore, but I like Copilot. You know, I think some people think I'm a doomer, that I think that it's all bad. I think there's plenty of great. I like the idea of it. But I often find that I just find it annoying. The problem is that I'm so much better than it. So it's like, why do I want to use something that I'm so much better than? Do I really want to spend my days trying to control an intern that's not good at it, that only does? I mean, the problem is when I'm not good at something, Copilot allows me to write code at a very fast rate using my assumptions and mirroring kind of my coding technique for some amount, and steers me into my already bad idea at a rate that's so fast.
Where the scale is going to be such that this can just do anything. Right?
So I don't really like Copilot.
Then there's the perhaps slightly more reasonable, should we say, pragmatic interpretation, which is like, just call it balanced, right? Which is, but there's a sort of linear movement, right? So the idea is that we have to add a lot of...
By the way, there's no technology that's like linear movement. You know, the speed of computers they have not linearly moved. Tech does not linearly move. It's like an inverse tangent. It goes slow, it goes fast, it goes slow.
Examples, but we are going to get a decent performance.
Linear on a log scale.
So we just keep adding examples, we'll keep getting better, and that's going to be great. And remember that if we ended up here, we have something that could take any image and tell you exactly what's in it under any circumstance, right? That's kind of what we're aiming for. And similarly for large language models, this would be something that could write with incredible accuracy on lots of different topics. Or for image generation, it would be something that could take your prompt and generate a photorealistic image of that with almost no coercion at all. Right? That's kind of the goal. This paper has done a lot of experiments on a lot of these concepts across...
By the way, those were very different answers, which is kind of surprising because the difference between generating an image from a prompt versus generating a problem solved from a prompt are very, very different. And I think that's something that people don't talk about a lot because when it comes to an image of anything, whatever you want, I want a star and I want the star to be very pretty. Bing, everyone's all very happy about the star. Like the amount of stars that could possibly exist within this thing is just gigantic, right? There's just so many possibilities. But if I say I want you to sum numbers, there's not that, right? There's not that many possibilities. There's like a reduce or a fold. There's like a boomer loop, right? There's a boomer loop. And then what else? Maybe recursion? That's really it. The amount of possibilities are very, 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 very tiny because there's an exactness to this answer. There is a level of impreciseness that makes this thing work out. And so you find that these ones, you always get the right answer. And this one, you don't get as many right answers. A boomer loop, it's just that's literally just a for loop. For I equals 0 up to 100, right? Boomer loop detected. You have to use I, right? That's the problem, is that this is a precise answer. There is not any variation of being incorrect on here. And so this makes it a fundamentally hard problem. You can be incorrect in all sorts of reasons here, and this works, right? This is okay. You can be imprecise all over the place, and it's perfectly fine. This is part of our visual inspection, right? It's okay to be incorrect. My wife is in the paramedic school, and she's absolutely certain that ChatGPT is going to kill people because precision. Yes, precision is very, 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 very is a really huge problem, and because these two are fundamentally different problems. They're like so different that it's like they're worlds away, right? They're literally two separate problem islands, and you can take this one. You can take this one and you can move it into this one really easily. And how you move it from here into here, I did almost grade boobas at this point, is very, very simple. The all white canvas problem, right? Tell it to generate a problem that's all white, all black, all whatever, right? And you will actually, you will bamboozle it because the problem went from any variation of these are correct to there is a specific, precise answer. Yes, I had nipple ring bobs on there for a second.
A lot of models across a lot of downstream tasks, and let's call this the evidence.
I thought you were going to call it pessimistic then. But
It is pessimistic also, right? It's logarithmic, so it basically goes like this, right?
flattens out.
It flattens out. Now, this is just one.
Has anyone ever trained handwriting? So one of my first requirements when I was getting my master's in AI was training handwriting. So we'd receive a handwriting set of data, and along with its classification, and then a second set of data that is just handwriting. And we would go out there and you'd have to like learn how to train it, right? And so yes, the minced data, is that what it is? Is that the classic one, the 10,000 points of handwriting data? Classic minced? Yeah, okay, yeah. So we did RBF and we did MLPs, and RBF did really, 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 really well because RBF was interpolating between a known data set, whereas the MLPs you had to train a lot longer, and eventually if you trained it enough, it would do a pretty good job. And so it was kind of this like really weird experience where you realize that, okay, I've trained it on this thing, and now I'm going to give a new piece of data that's just slightly different, and all of a sudden it just completely, like, it cannot classify it at all. And this was really my understanding of AI at that point, which was the amount of training you have to put into it for it to be able to even interpolate between two of the same sets becomes huge. RBF stands for radial basis function. It does not mean a resting bitch face. Generalization is like that level is extremely difficult, right? There's also mind mints, which is someone's brainwaves while looking at mints. Oh, really? That's pretty neat. It's kind of cool. It was a very cool experience. I absolutely loved that.
On paper, right? It doesn't necessarily.
That's, by the way, this is why I think LLMs are so incredible, is that it can solve really hard programming problems. This is one of my favorite ways someone described it to me. You don't use ChatGPT or these new LLMs. Their power is not in solving easy to program problems. Make me a UI. Let's make this button. Let's call this function. Let's make a REST endpoint. Those are easy to program problems, which are actually somehow excessively difficult for a GPT. But let's solve difficult problems. Is this a beer bottle? Is this a shot bottle? Yes or no? Now, an LLM might be able to look at this and go, no, it's not. It's actually a vitamin. It's a B12 bottle, right? They might be able to say it's something different. So GPT actually has the power to be able to see these kind of things much, much different than us. And that's like a super hard problem to program. whereas it's not a hard problem to jippity on. And so that's a shiv. Right? Hot dog or not hot dog. And so that's kind of one of these incredible kind of experiences. Oh, what's that? Look what my wife gave me. Some grass-fed beef jerky, mango habanero. Let me try it. Let me give this a try. What a nice wife. Flip, take it out. Flip, take it out.
Necessarily mean that it will always flatten out. But the argument is, I think, that, and it's not an argument they necessarily make in the paper, but the paper's very reasonable. I'm being a bit more cavalier with my wording. The suggestion is that you can keep adding more examples, you can keep making your models bigger, but we are soon about to hit a plateau where we don't get any better, and it's costing you millions and millions of dollars to train this. At what point do you go, well, that's probably about as good as we're going to get for technology, right? And then the argument goes, we need something else. We need something in the transformer or some other way of representing data or some other machine learning strategy or some other strategy that's better than this in the long term if we want to have this line go up here or this line go up here. That's kind of the argument. And so this is essentially evidence, I would argue, against the kind of explosion possibility of that you just add a bit more data and we're on the cusp of something. We might come back here in a couple of years, if you'll still allow me on Computer File after this absolute embarrassment of these claims that I made. And we say, okay, actually the performance has improved massively, right? Or we might say we've done.
I would bet that it's not going to improve massively. I would be shocked. Honestly, I'd be so shocked if it improved massively.
Doubled the number of data sets to 10 billion images, and we've got 1% more. Right.
I'm more curious how this is going to go because, one thing that was very interesting is that Sam Altman made some sort of claim about the difference between GPT-4 and GPT-5 and how he's pretty sure GPT-5 is going to be better than GPT-4. Like, that wasn't necessarily like a winning endorsement. I think we're already hitting some of those things because, I mean, we're in this weird phase where we're hitting just how amazing these things. I bet those orgies help. Yeah, the weird CNC parties with heavy uses of LSD, as they say. That's wild. Shouldn't even say, just crazy right there. Crazy. 4 is already not much better than 3.5. Yeah, I mean, it's better, but it's not massively better. Now, the real question is going to be compute power. Power versus machinery, right? We have a whole problem of machine time, and we have a problem of compute power. Sorry, people are saying what? For those that don't know, there's this whole thing that went on Twitter just recently. Let's see if I still have it up somewhere. Shut up, Warren! Where is it? Oh, yeah. To the journalists contacted me about AGI consensual, non-consensual CNC sex parties. Also, a heavy use of LSD among some of the elite AI researchers. Blah, 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 blah. This is spawned from this Jan fella doing ML research on OpenAI. So I don't know. It's just crazy. It's just crazy tweet. Okay. That's why my only response to it was, what? What? We would have lost you to the AI sex parties. You would have lost me to the AI sex parties and LSD if I wouldn't have changed. That would have been it. I would have been an AI coomer instead. I would have been, but now I'm not. But I am curious, can we even sustain the amount of power? Because if we need to 10x the amount of power and compute, that's a lot.
On the classification task, which is good, but is it worth it? Well, I don't know. This is a really interesting paper because it's very, very thorough, right? If there's a lot of evidence, there's a lot of curves, and they all look exactly the same. It doesn't matter what method you use, it doesn't matter what data set you train on, it doesn't matter what your downstream task is.
This poor curve actually went down. A little flaccid on the curve. This one's like, ugh. This one's feeling a little, I mean, I can't quite tell what they are. I don't know what obviously we haven't read the paper, but I mean, still. You don't want to be this guy. You don't want to be this. You don't want to be this data set where they pre-trained. Look at that. They 10x the conceptual frequency training, and it went downwards. This is also pretty crazy. 100x the difference with almost no big wins here.
Is the vast majority
That's
of them
just
show
overfitting.
this.
It could be overfitting. You are right. It could be overfitting. I don't know. I don't know the extents, but I would assume that the people doing the research, I mean, overfitting is like your classic AI 101 course. You build your first MLP. They give you the Rosenbrock function. You do the Rosenbrock function, and then you realize you've done too much. It's kind of a classic. It's kind of a big-time classic one.
This kind of problem. And the other problem is that we don't have a nice even distribution of classes and concepts within our data set. So for example, cats, you can imagine, are emphasized or overrepresented, yeah. Overrepresented in the data set by an order of magnitude, right? Whereas
Shrimps aren't.
specific planes or
In other words, what he's trying to say is that people really think cats and dogs are cute, and everybody's like, yo, screw those shrimp, okay? Put them in a cocktail, and we'll have a party, okay? You bring out Mr. Bigglesworth, and we'll give Mr. Bigglesworth a pet, and then we'll just absolutely eat all the shrimp. No one cares about it. No one has the cute shrimp photos.
or specific trees are incredibly underrepresented because you just have tree, right? So, I mean, trees are probably going to be less represented than cats anyway, but then specific species of tree, very, very underrepresented. Which is why when you ask one of these models, what kind of cat is this, or what kind of tree is this, it performs worse than when you ask it, what animal is this, because it's a much easier problem. And you see the same thing in image generation. If you ask it to draw a picture of something really obvious, like a castle, where that comes up a lot in the training set, it can draw you a fantastic castle in the style of Monet, and it can do all this other stuff. But if you ask it to draw some obscure artifact from a video game that's barely even made it into the training set, suddenly it's starting to draw something a little bit less quality.
Yeah.
And the same with large language.
Little less quality. Okay. Is that how we're referring to that? Draw a centaur. Yeah. Yeah, that makes perfect sense. It just does.
Language models. This paper isn't about large
AKA
language
shit.
models, but the same.
By the way, obviously the reason why cats are the most prevalent is actually a very interesting intersection that you may not have caught on to. But there is this really unique intersection of Arch users, cat girls, cats, and LLMs. And I think that because they all have been put together, cats are just the most recognizable creature from LLMs. Second most being cat girls, actually being the next most recognizable creature.
Same process you can see actually already happening. If you talk to something like ChatGPT, when you ask it about a really important topic from physics or something like this, it will usually give you a pretty good explanation of that thing because that's in the training set. But the question is,
Slightly better Google search. Let's go. It literally ChatGPT just summarized the Wikipedia page for me. That's all that is. This is just Wikipedia, just without all the Wikipedia. Right, like I don't need to be like, well, the very first, phases. I mean, you're just like, dude, just tell me what it is
what happens when you ask it about something more difficult, right? When you ask it to write that code, which is actually quite difficult to write, and it starts to make things up, it starts to hallucinate, and it starts to be less accurate, and that is essentially the performance degrading because it's underrepresented in the training set.
So I actually disagree with him on this take. I think that it's not about that. It's about the preciseness. Because I think that preciseness is just like copy pasting a simple keywords from a Wikipedia article, right? It's just like this is such a strong tied one, and maybe he's right. Maybe I'm understanding it. Maybe I could be wrong here, but I feel like the difference is that you can't. Yeah, okay. Actually, I do agree with him. The underrepresentation in the training data, meaning that every time you come across any novel thing or the thing you're trying to program in context of what you're trying to program has never really been done before. So it's kind of between these 2 points of extrapolation. It's trying to like island hop between these two concepts, and so you just get this less precise, less accurate version with hallucinations. Okay, sure. Yeah, I mean, okay, I can buy it. You know what? I'm wrong. He's right. I don't know why I doubted the computer file guy. I mean, he even has like a British accent. He got British and that. All right, isn't that a pretty good one? Right now, the only accent I can do is Kano. That's it.
The argument, I think, is, at least it's the argument that I'm starting to come around to thinking, if you want performance on hard tasks that are underrepresented on just general internet text and searches, we have to find some other way of doing it than just collecting more and more data, right?
Whoa. I don't think I could do Keanu beyond Arno Kung Fu. Wow, Morpheus. Morpheus. But what is the Matrix? Wow.
Particularly because it's incredibly inefficient to do this. Right? On the other hand, these companies they've got a lot more GPUs than me, right? They're going to train on bigger and bigger corpuses, better quality data. They're going to use human feedback to better train their language models and things. So they may find ways to improve this, up this way a little bit. as we go forward. But it's going to be really interesting to see what happens, because will it plateau out? Will we see ChatGPT 7 or 8 or 9 be roughly the same as ChatGPT 4, or will we see another state-of-the-art performance boost every time? I'm kind of trending this way, but it'll be exciting to.
Okay, I got one more impersonation request, which is the shop sales girl from Kakariko Village that sells both the arrows. You're welcome. That is the end. By the way, this thing that he's saying is very interesting because it also is kind of glossing over the fact that training data is becoming more sparse. More and more of the internet is comprised of data generated by LLMs, right? So now you're getting the average of an average, which is not going to be good. Not safe for, Flip, don't take it out, right? Which is, that's going to be a real problem. Girl Primogen is not real. He can't hurt you. Can he? Jippity 40 is going to have like zero hype. It is. I'm actually very curious what's going to happen to the point where, can GPT-7 even exist if 80% of the internet is GPT traffic? I know they're trying to solve it, but it's a really hard problem to solve. It may not be solvable. I know they're pooping in the well. There they go, shitting in bed again, people.
To see if it goes this way.
Take a look at this puzzle devised by today's episode sponsor, Jane Street. It's called
Jane Street mentioned. Did we just get Jane Street mentioned? Did we just get OCaml mentioned? Did we just get Teach Streams? By the way, Teach TV, everybody. Teach TV.
Bug.
By the way, I cannot believe that TJ somehow got mentioned even in this video. This is upsetting that somehow TJ even wormed his way into this one.
Right, inspired by debugging code, that world we're all too familiar with where solving one problem might lead to a whole chain of others. We'll link to the puzzle in the video description. Let me know how you get on. And speaking of Jane Street, we're also going to link to some programs that they're running at the moment. These events are all expenses paid and give a little taste of the tech and problem solving used at trading firms like Jane Street.
By the way, Jane Street's a pretty cool company. I know typically people are not big fans of trading stock financial companies, and generally you're probably not far from Wolf of Wall Street going on. But man, they also prop up the OCaml community, and there's really smart engineers there. A lot of Giga Chads on the keyboards. Pretty cool. Pretty cool stuff. Citadel mentioned it's a little. They don't seem to have as much of a negative outlook as Citadel. But they're what they produce is pretty cool. I am very, very excited about the cool engineering they produce. I think it's pretty amazing.
Are you curious? Are you a problem solver? Are you into computers? I think maybe you are. If so, well, you may well be eligible to apply for one of these programs. Check out the links below or visit the Jane Street website and follow these links. There are some deadlines coming up for ones you might want to look at, and there are always more on the horizon. Our thanks to Jane Street for running great programs like this and also supporting our channel. And don't forget to check out that bug bite puzzle.
Okay. Thanks, Computer File. And thank you, Jane Street, for sponsoring Computer File. That was great. That was a great video. It is a very interesting... By the way, there's me with a microphone in Brazil wearing a Brazilian jersey. Brazil mentioned, by the way. I do like this whole thing. This is very, very interesting area. I think it's not shocking that I'm on the probably not going to move as fast side of things. And the only reason why I'm on the probably not going to move as fast side of things is that, I've just been around long enough to see that technology goes, it's not as exciting, right? Things always start super exciting and tend to fizzle out. So I'd be personally very surprised if this thing actually, doesn't do that. Energy is huge. Yeah, there's a lot of hype cycle. Same with COVID. I read things before I actually process them in my head. Let's see. Hold on. I completely agree with all your views on ML and AI. Really, I'm surprised. Some of them must be wrong. Just an interesting question about its progression. I always ask myself, how is this technology different from the other ones? The hype over is understandable, crazy, but people were also doubtful about cars and other stuff in the 1900s. Would love to hear your take. Well, there's a huge difference, though. There's There's so many different things about, especially with cars. One hard part about cars is that there was also just not like infrastructure that was required for people to have cars. That's much, much different. Whereas we already have all the infrastructure for people to have AIs, to be able to have access to the AI. It's just that we have a compute problem, right? We have an infrastructure problem on a different side. So you, the consumer, can use it. But you, the producer, well, you're the ones that actually have to struggle a little bit more on that, like, whole topic. And so it is fundamentally different. But like all adoption of all technology, it takes time. Even if AI were exceptionally better than it is now, we would still be about 10 years off before it's actually in every single company. It just will. Cars don't require new physics. Yeah, that's also true too. It's just a fact of life. No matter how, and that's assuming AI in like its most amazing stance. Yeah, exactly. The I stands for intelligence. For those that don't know this article, it's just about the horrors that are happening on security and open source and just the issues that are coming in. And so that's like a huge problem, is even if it was amazing today, right now, and solved a huge classification of problems and actually was a junior engineer that you could use, like a real junior engineer, someone that was full of energy and was able to solve all the problems and with actually come up with new solutions, actually be a junior engineer, it would still probably take 10 years before everyone's fully using it, because the first iteration of companies using it, there's going to be a whole series of things that go terribly wrong. Who knows about the lawsuits from what kind of training that has been used, all of that. There's like all sorts of things that are going to happen. A huge amount of risk management that has to like go forward. There's all these companies that just forbade the use of Copilot because the use of Copilot is also selling your information. There's like all sorts of just like company-based hurdles. So making the assumption that AI is amazing today, we're still looking at a huge gap before people would even start using it everywhere. So now let's pull it back and say where AI is today, the amount of companies that can really take advantage of it is going to be on the individual level, right? Can I use Copilot at my job? Yes, I can. I will use it and see if I like it or don't like it, right? That will be like a whole thing. It'll be an individual one. There's one advantage of Gypity versus human. Gypities are infinitely patient. Are they? You can talk rudely to a Gypity and you get worse results. You can talk nicely and remind it to breathe and it'll do better. Like, this is a well-known kind of weird aberrant behavior in LLMs, is that they're mirrors, right? They're mirrors of people. You treat the more terse you talk to an LLM, the worse your answers are. The nicer and kinder you are, the better your answers are. Also, time of the year. Yeah. It turns out if you change the time of the year, you get worse answers. Just make sure it's always in July. Yes, but you can also restart 1,000 times with the same discussion or code task. Sure. We're just going to say, hey, you're right. You win this one. Invert it. You talk to a person who doesn't have patience, who doesn't have all these things, right, that this magically amazing AI has, and you ask it a question. You know what it's going to do? It might tell you have an XY problem. You're asking for X, but what you really are asking is Y. You're off. You're wrong. You're incorrect on your entire fundamental presupposition, meaning that what you're trying to do is the wrong way from the get-go. AI is not going to spot that for you. AI is going to give you all the best answers to do what you're supposed to be doing incorrect, right? The XY problem. It's kind of like a well-known problem in our world, which is a very obvious problem where you want to solve problem X, so you figure out you need to solve it by solving problem Y. You go and ask about problem Y, and you're going off on a completely wrong direction. And so, certainly, you're totally correct. Here's the version of, right, the XY problem, the XY problem. It's very, very good. I love when someone learns about the XY problem and tries to tell me that when I'm clearly searching for my X. Yeah. I'm clearly searching for my X. XY problem. Should be solving X, but you're solving problem Y. Yeah. Yes, effectively. That's the gist is like, let's say that you have been given some task, and the task is like you have to remove all the, you have to prevent people from, what's a good way to describe this? I can't think of a good way to describe it, but you get the idea. You're asked to do some sort of task, and you realize there's a roadblock in doing your task. You find a way to work around your task. You start working on that. You run into a new problem in which seems and appears very small, so you go and ask, how do I solve this one thing? Now, people will go, well, wait a second. This kind of seems like an odd way to use our system, and they're trying to work through that problem with you, not realizing that you're trying to solve a completely different problem. The done goofed problem. Anyways, the name is it's very interesting. So I please take a moment and realize that things they typically don't grow linearly, and they typically don't grow exponential. They typically grow like that. And it just gets real sag in this area. And so it'd be very interesting if, for whatever reason, AI breaks this typical thing that you should expect. Usually you expect law. You usually expect log. You don't expect the other way. I drew that all wrong, and it really bothers me. It should really be like this, and then log should be really like that, right? This is usually what you're seeing, right? And so I think we're just right here on AI. I think we started with nothing. Like 3 years ago, there was nothing. And now we have something. And so where are we? What line are we on is what you really have to figure out. We could very well be right here, and we just don't know. Okay, a gen.